Imagine that in the 2000s, at a European city port, workers are unloading an ordinary container of Chinese ceramics. Nothing special, just a routine operation. But inside, among the pots and vases, hides a creature the size of a large thumb that, within 2 decades, will turn an entire continent's beekeeping into a disaster zone. One fertilized female was all it took to trigger a biological catastrophe that's now almost impossible to stop. Today, we're talking about the Asian hornet and why Europe has proven powerless against this predator. Subscribe to the channel, it's going to be interesting. The Asian hornet, known to scientists as Vespa velutina nigrithorax, originates from Southeast Asia. Its natural range covers territories from China to India, where it has existed for centuries in ecological balance with local insect species. Visually, this predator looks menacing. Queens reach a length of about 30 millimeters. Workers are smaller, approximately 20 millimeters. The main distinguishing feature is yellow legs, which gave it its second name, the yellow-legged hornet. The body coloration is dark, almost black, with narrow orange stripes on the abdomen. This camouflage makes it less noticeable during hunting, especially against tree bark and foliage backgrounds. But the real danger isn't in the size or coloring. The Asian hornet is a highly efficient predator with a unique hunting strategy. In its native environment, it hunts various insects, but especially loves bees. Asian honeybees have learned to defend themselves by surrounding the hornet and creating a living ball around it that heats up to 47 degrees. The hornet dies from overheating. European honeybees have no such defense. They've never encountered this enemy in their evolutionary history, so they turned out to be completely defenseless. And then, in 2004, fate brought them together in the most unexpected way. The invasion story began at the port of Bordeaux in southwestern France. Researchers believe a container with ceramic products from China's Jiangsu province arrived there in the fall of 2004. Inside the packaging, among the straw and cardboard, at least one fertilized Asian hornet queen was hiding. She survived the long journey across the ocean in a state of hibernation. After overwintering in French soil, the queen woke up in the spring of 2005. She needed to find a place for a nest and start laying eggs. Here lies the key feature making Vespa velutina so dangerous. Just one fertilized female can establish an entire colony. She doesn't need a group of individuals, doesn't need workers to start. She begins alone, building an embryonic nest the size of a walnut. The queen herself molds the first cells from wood pulp mixed with saliva. The first eggs are laid in April or May. After several weeks, larvae emerge, which the queen feeds by hunting small insects. By early summer, the first worker individuals appear, small, sterile females. From this moment, the queen stops leaving the nest and focuses only on laying eggs. Workers take over construction, hunting, and colony defense. The growth rate is impressive. One colony per season can lay up to 15,000 eggs. By late summer, the nest reaches sizes up to 1 meter in height and 70 centimeters in diameter, containing about 12,000 cells. For comparison, the European hornet builds nests with only 3,000 cells. The first observations of Vespa velutina in France were registered in 2005. Scientists didn't yet understand the scale of the catastrophe. It seemed like a local phenomenon, a single case of exotic species introduction. But the hornet had already begun its victorious march. By 2009, there were already several thousand nests in the Bordeaux area and neighboring departments. The spread rate astonished specialists. The hornet moved at a speed of about 70, 80, and according to some data, up to 100 kilometers per year. This speed is explained by several factors. Young queens in autumn fly significant distances searching for wintering sites. They can cover dozens of kilometers independently, establishing new colonies in spring far from the parent nest. Humans unwittingly help the spread. Queens often winter in secluded places, in wood piles, garden furniture, building materials. When these items are transported long distances, hornets travel with them, bypassing hundreds of kilometers in one night. By the end of 2015, Vespa velutina had colonized almost all of France. This meant that in 11 years, one species had captured a country with an area of over 600,000 square kilometers. France became a launching pad for further expansion. Now it's time to talk about exactly how the Asian hornet turns apiaries into disaster zones. Its hunting tactics, honed by millions of years of evolution, work with frightening efficiency. The method is called hawking, meaning hovering, hanging in the air. A worker hornet takes position in the air directly in front of the hive entrance at a distance of several centimeters. It hovers motionless, like a miniature helicopter, waiting for prey. As soon as a bee flies out of the hive, the hornet attacks with lightning speed. It grabs the bee with powerful jaws right in flight, kills it within seconds. Then it bites off the head, wings, and abdomen, leaving only the thorax, rich in protein. This protein ball the hornet carries to its nest, where it feeds the larvae. In a day, one worker hornet can kill up to 50 bees. Imagine that 5, 10, 20 hornets are on duty in front of a hive simultaneously. They simply exterminate the entire workforce of the bee family. Bees can't fly out for nectar and pollen because death awaits them at the entrance. They lock themselves in the hive, experiencing stress, stop collecting food. Honey supplies are depleted, brood starves, the family weakens and can ultimately perish. French beekeepers began sounding the alarm by the end of the 2000s. Losses of bee families in some regions reached 30%. This is colossal damage, especially considering that beekeeping already faces multiple problems. Economic damage is measured in millions of euros annually. Bees not only produce honey, they pollinate agricultural crops. A decline in bee population directly affects the yield of fruits, vegetables, and oilseed plants. Vespa velutina isn't limited to just bees. DNA analysis in hornet larvae intestines showed a surprising diversity of prey. The diet includes bumblebees, various wasp species, flies, and butterflies. This omnivory makes the Asian hornet even more dangerous for ecosystems. It easily switches to other insects when bees are scarce. From France, the wave of spread rolled further. In 2010, hornets were discovered in Spain, in the north of the country, in the Basque country. Mountains didn't become an obstacle, hornets flew over the Pyrenees. In 2011, nests were found in Portugal and Belgium. 2013, Italy. 2014, Germany. 2015, Switzerland. 2016, the United Kingdom. The geography of conquest expanded every year. The United Kingdom, with its island position, hoped for natural protection, but hornets overcame even the English Channel. The first finds on the island of Jersey, located close to the French coast, happened earlier, and then hornets appeared on the main island. By 2017, Vespa velutina had established itself throughout France and was actively colonizing neighboring countries. The total captured area amounted to hundreds of thousands of square kilometers. Interestingly, settlement didn't proceed as a uniform front, but in leaps. Genetic material analysis showed that the main part of the Western European population apparently originated from one invasion, most likely from that very queen from the 2004 container. This means the genetic diversity of the European population is extremely low. All millions of hornets on the continent are descendants of one female. It would seem this should make the population vulnerable, but in practice, low genetic diversity didn't prevent successful expansion. In 2019, hornets reached the Balearic Islands. In 2024, they were recorded in Czechia, moreover at a distance of more than 1,000 kilometers from the nearest known populations. This is clearly the result of accidental transport with cargo along highways. But why, despite all efforts, has stopping the Asian hornet proven practically impossible? There are several reasons, and they all add up to a perfect storm of uncontrolled invasion. The first reason is reproductive biology. As already mentioned, one fertilized queen is enough. In autumn, each mature nest produces up to 350 new queens. Imagine, one nest produces 350 potential founders of new colonies. Even if 90% of nests in a region are destroyed, the remaining 10% will release thousands of queens. By spring of the following year, the population will recover with ease. Such reproductive power makes the hornet almost invulnerable to traditional control methods. The second reason is nest concealment. Vespa velutina builds its nests high in tree crowns, usually at heights over 10 meters and sometimes up to 25 meters. The nest is camouflaged by foliage. It's hard to spot from the ground until late autumn. When foliage falls, the nest becomes visible, but by this time queens have already flown away and hidden for winter. Destroying an empty nest has no effect. The nest needs to be found and destroyed in summer or early autumn, but precisely at this time it's hidden. Attempts to use traps with baits showed limited effectiveness. Traps attract worker individuals, but their death doesn't critically affect the colony. The queen continues laying eggs. New workers appear constantly. The third reason is the huge area of infested territory. By the mid-2020s, hornets had spread over an area of millions of square kilometers. Organizing comprehensive monitoring and nest destruction over such an area is physically impossible. France spends millions of euros annually on control programs, but even with the destruction of tens of thousands of nests per year, the population doesn't decrease. Every year, tens of thousands of new nests form, compensating for losses. The fourth reason is Europe's climatic suitability. Climate change only helps the Asian hornet. Warming winters increase the survival of wintering queens, expanding the potential range to the north and east. Modeling shows that climatically suitable territories for hornets include not only Western, but also Central, and even parts of Eastern Europe. There are no natural climatic barriers that would stop the settlement. The fifth reason is the absence of natural enemies. In Asia, the Asian hornet has enemies and competitors. In Europe, there are practically no such enemies. European birds aren't accustomed to hunting large, aggressive hornets. The sixth reason is inadvertent human transport. As the case in Czechia showed, hornets are regularly transported long distances in trucks, containers, and trains. Wintering queens hide in secluded places and travel with goods. Each such accidental transfer creates a new invasion focus, bypassing natural barriers and accelerating spread rates. Completely preventing such transfers is impossible. The volume of freight transport in Europe is too large. The United Kingdom is trying to hold back the onslaught by mobilizing citizens. A special smartphone application has been created where you can upload a photo of a suspicious insect. A system using artificial intelligence recognizes Vespa velutina with high accuracy. The National Bee Unit responds quickly to reports, travels out, tracks hornets to the nest, and destroys it. In 2023, 72 nests were destroyed. In 2024, 43. A decrease in the number of discovered nests might seem like success, but experts are cautious in their assessments. The overall trend is still upward, and no one can guarantee that the United Kingdom will be able to stop the species from establishing itself on the islands. On the island of Jersey, located very close to the French coast, the situation has already gotten out of control. In 2023, 339 nests were found there. In 2024, 262. Local beekeepers and volunteers openly admit that eradication, meaning complete destruction of the species, is impossible. They've shifted to a population suppression strategy, trying to at least reduce damage to apiaries. Complete victory is unattainable in their geographical position. Scientists are studying biological control possibilities. The idea of introducing specific parasites or pathogens from Asia is being considered, but this is extremely risky. Introduction of a new biological agent could cause unpredictable consequences for European ecosystems. Pheromone traps that specifically attract precisely Vespa velutina are also being researched. Automatic monitoring systems with cameras and artificial intelligence capable of detecting hornets at feeders near apiaries are being developed. Some beekeepers install protective nets in front of hives, narrow entrances to make hunting difficult for hornets. This provides some effect, but doesn't solve the problem completely. Hornets simply wait for a bee to exit beyond the protected zone. People fear Asian hornets. Although away from the nest, they usually don't show aggression. Stings are painful, but rarely life-threatening, except in cases of allergy. However, when approaching a nest, the risk of attack sharply increases, and colony defense can be fierce. Mass hysteria and fear sometimes lead to unsystematic nest destruction without coordination with authorities. This creates a monitoring problem. If people destroy nests themselves without reporting to specialists, important information about species spread is lost. Educational programs try to teach people to distinguish the Asian hornet from other species, explain the importance of reporting finds. But such programs have limited reach. Far from all residents of infested regions are aware of the problem. Changes in land use also favor hornets. Expansion of forest areas in some European regions creates more potential places for nest placement. Simultaneously, urbanization creates rich food sources. Cities become an ideal habitat. International cooperation in fighting Vespa velutina is developing. Data exchange between countries is ongoing. Common databases of nest findings are being created. Coordinated strategies are being developed. But political and bureaucratic barriers slow the process. The European Union has recognized the Asian hornet as an invasive species posing a threat to biodiversity and the economy. Funds are allocated for research and control, but the scale of the problem requires much larger investments. Climate models predict that by mid-century, the range suitable for Asian hornets could expand even more. Scandinavia, the Baltic states, even the western part of Russia could be under threat. The hornet will continue its movement north and east. This means the problem will only grow. More countries will face invasion, more ecosystems will be affected, more economic losses. The Asian hornet is not a temporary nuisance, but a long-term challenge for European nature management. It's still not entirely clear how the massive presence of Asian hornets affects wild pollinator populations, ecosystem structure, and food chains. Some studies show that bumblebees, despite being part of hornets' diet, are often able to escape attack thanks to their maneuverability. Long-term consequences may manifest over decades. A decline in pollinating insect numbers will lead to changes in plant communities, which will affect birds, mammals, and the entire ecosystem as a whole. Cascade effects are difficult to predict in advance. The Asian hornet story is a lesson about how fragile ecological balance can be. One random individual surviving a journey in a container changed the face of an entire continent in 2 decades. Trade globalization carries not only economic benefits, but also biological risks. Billions of tons of cargo are transported around the world annually, and thousands of species of organisms travel with them. Most don't take root, but some, like hornets, find a new home and begin an invasion. Cargo control for biological species is extremely complex and expensive. The UK experience shows that with prompt actions, there's a chance to stop invasion at an early stage. But constant vigilance, citizen participation, and funding are required. Just ease up on control, and the species can break free from it. For European beekeepers, the Asian hornet has become a new reality they have to live with. They're learning to adapt, changing practices, installing protection, sharing experience. This is a long struggle with no quick victories. Interestingly, in some regions, local predators are beginning to learn to hunt hornets. Individual bird species, for example, European bee-eaters and shrikes, have been observed eating Asian hornets. Perhaps over time, a new ecological balance will form. But this is a process requiring decades, if not centuries. European bees won't develop a defensive mechanism similar to Asian ones in a few generations. Natural adaptation is too slow a process for solving the current problem. Technological solutions, such as drones for nest searching, thermal cameras for detecting heat signatures of nests in tree crowns, insect activity sensors, are being developed and tested. Perhaps they'll become a breakthrough in monitoring and control. But any technology requires investments, personnel training, and infrastructure. Not all countries and regions can afford such expenses. Inequality in resources leads to inequality in invasion control effectiveness. The Asian hornet story in Europe is a drama of biological invasion unfolding before our eyes. From one random individual in 2004 to millions of predators across the entire continent in 20 years. Most experts agree that complete eradication of hornets from Europe is already impossible. Reducing numbers in critically important areas, protecting apiaries, training beekeepers in countermeasure methods. This is a reminder that nature doesn't forgive mistakes and that the consequences of our actions can be unpredictable and irreversible. Write in the comments what you think about invasive species and whether anything can be done to prevent future biological invasions.